Now we're going to use our superposition to talk about interference. Interference of waves. So the way we're going to do it is we're going to think about superposition of, and instead of those pulses, we'll do traveling waves. Uh-oh, US or British? Oh, I like to keep it classy. Waves. Superposition. Okay. So let me draw two traveling waves. So by traveling waves, I mean that sinusoidal wave that moves along, right? So say we have one like this, and it's moving, and we have another like this, and it's moving. Pretend I drew them at the same wavelength. Everything is the same. Two identical waves, both moving to the right. How do we add them? Superposition. You just add the two values. So we add them by superposition. Add, but the result depends on how they line up. If you think about it, where is this one relative to this one? That's called the phase of the wave. Where you are within the sinusoid, where you are within the oscillation is the phase. So where one is relative to where the other is will affect how they add. So one way to think about it is if they are what we call in phase. Okay, if they're in phase, that means where one of them goes up, the other one goes up. So if we label them 1 and 2, then when 1 is positive, 2 is positive. And when 1 goes negative, 2 goes negative. 1 goes back positive, 2 goes back positive. Well, if you add those two, you can see what's going to happen. If you superpose, it's a verb as well. If you superpose those two, you can see what's going to happen. You'll get just twice as much amplitude. Okay. So that's in phase. That's what we call constructive interference. And you can probably see why it's called constructive. I can show you constructive interference. So it's hard to get two waves on a string at the same time. Not easy to do. So we can do it with sound, though. We can send sound waves through the air, and sound waves kind of spread out, and they naturally want to combine. So here I have two speakers hooked up to a single function generator. So this is going to make a sinusoidal vibration of the speaker diaphragm, which is going to send out a sinusoidal pressure wave that we call sound. So let me turn it on. And let's crank it to 300 hertz. I find 300 hertz quite soothing. Okay. So right now, I have them hooked up electrically to where they're in phase. This one is making a sinusoidal wave, this one is making a sinusoidal wave, and they're both going together. So the sound that they make adds. If I take one out, you can hear it got a little lower in amplitude. And if I add the second one in phase, then you can see the amplitude goes up. Now, what if they're not aligned in that nice way? That's called out of phase. Okay, if they're out of phase, it looks like this. Here's 1 and here's 2. While 1 is high, 2 is low. And while 1 goes down, 2 goes up. And while 1 goes up, 2 goes down. And I bet you can guess what the superposition is going to look like. Everywhere you add these, you get 0, right? You get nothing. So the superposition gives you nothing. They cancel. You could say the waves cancel because they're out of phase. And you could also label this destructive interference. These are the two kinds of interference. So I can show you that as well. If we turn our sound waves back on, go back to 300 hertz. Same volume. They're in phase. So now what I'm going to do is take the right one off. Amplitude went down a little bit. And I'm going to turn this over. If I turn this over, I'm taking the same sinusoidal voltage and just applying it out of phase. I switch the two electrodes that move the diaphragm. So this was how it was, constructive, louder. But now I'm going to make it destructive. And when I turn this around and add them, it gets quieter. it doesn't quite go to 0 because there's waves bouncing all over the place and this isn't ideal and everything. But you can hear the sound gets lower because it's destructive. And if I have it the other way, constructive, it gets loud. So that's a demonstration of constructive and destructive interference. And of course, there's everything in between, right? It doesn't have to be exactly in phase, exactly out of phase. You can have it slightly in phase or out of phase, and the amplitude would do other things. But these are the basic cases of wave interference.